Okay, so I am coming to you live from my room in second year. I'm in a different place now. I didn't just move in, I've been here for about 5 or 6 weeks now. I think it'll be 6 weeks tomorrow. So yeah, it's currently Friday. The reason why I've been gone for so long is that second year has hit me hard. I've got way more assignments this year. This year also actually counts as well. I've also picked up a weekend job, so I've got even less free time. I started going to the gym and I've been looking for placement years. So yeah, all in all, I haven't had a bunch of free time, but this past week I've had no lectures due to it being kind of like a break in the term. I thought I'd take this opportunity to quickly put something out, and I thought I'd come back to a classic, real analysis that seems to do the best on my channel. And yeah, let's take a look. This assignment came out, I believe, last week. It's been exactly a week since it's been out, and I haven't really made any progress. I've been too focused on other things, but let's take a look. It is three questions, so yeah, worth 100 marks in total. I'm gonna be careful with how far I scroll up because my lecturer's name and email is above this point. I don't want to reveal that. But yeah, let's take a look here. Let f be continuous. Suppose that f of x is greater than or equal to f of 0 for all x in the open interval -1 and 1. Part 1, if f dash of 0, if that limit exists, so the negative limit of this exists, show that f dash of that is less than 0, it's negative, so that's positive, so that it equals 0, finally. Um, uh, these first three seem very doable. I don't exactly know how I'm going to start them. I think I'm going to use first principles, maybe. That's my initial guess. I haven't really tried it all yet. These first three. Part 4, however, find an example of a continuous function which has a global minimum at x equals 0, for which f of 0, f dash of 0 exists, but for which f dash of 0 does not exist. Oh, f dash of those put the positive and negative limit of that derivative does exist, but at that point it doesn't actually exist. You can say this property is without proof. And I don't know how I'm gonna do that one. Yeah, but I just don't really. Yeah, we'll figure that one out. Question 2, let f be a real function that is thrice differentiable such that the infimum of f triple dash x is greater than or equal to m. Show that there exists a quadratic polynomial function q of x such that f of x is greater than or equal to q of x for all x in the interval 0 to infinity. That one of my friends said Taylor's theorem, and I'm not good at that. I'm not good at using Taylor's theorem in real analysis, so I might just take his word for it. But yeah, that one, who knows? My main goal is to complete the first three of this today, maybe even question 4, because I have a slight idea, but honestly, it's a shot in the dark. Then the final question is this one. Let p be a real number and consider the function f just defined as f of x when x is greater than 0 is minus x to the 4, less than 0 x to the 4, when x equals 0 equals p. Show that f is an element of. I don't actually know what this symbol means. This symbol might have been covered in a lecture that I missed because I just saw it on my laptop. That's a whole nother thing. Randomly throughout the night, my laptop died. I went to bed, woke up again in the morning, tried to turn it on, didn't turn on, tried to charge it, I wouldn't charge it, took it to the Apple store, and they said £450 to charge it. Of course, I couldn't afford that. A couple of weeks later, which is literally like 3 or 4 days ago, I plugged in the charger for jokes, just to see what would happen, and it turned on. Not complaining, but I think my laptop's on its last legs. But yeah, that's another story. Yeah, I don't know what that symbol means, but I'll figure it out and compute this integral. Um, This one doesn't seem too bad either. I just gotta, and I keep saying this, just gotta really just figure it out. Um, so yeah, honestly, I'm most confident about this first question. This one I think I'll be fine on. This one, that's gonna get done last. I just know it. Then this one might take me a while to figure out, but honestly, I think I could do it though. So yeah, that's the assignment. What have we looked at this year in real analysis too? So we started integration. I mean, no, sorry, not differentiation. And last year we did differentiation. What else? We started talking about partitions as well. Um, what else have we started talking about? Yeah, upper Riemann sums and all the kind of stuff and lower Riemann sums, all stuff that's needed for that integration stuff. Um, what else? Let me get this up actually. That didn't do what I thought it would do. So yeah, this is what we're doing for the autumn term, just in total. We're halfway through. I believe we got to here. I think this is where we stopped. The theory of Riemann integration. But I'll do a quick tour what else we've done. So yeah, we looked briefly at limits, continuity, and differentiability, just as a refresher. What else? I believe we also looked again at infimums and supremums to make sure we remembered what that was. Yeah. While scrolling through this, I just want to say my lecturer revealed the average score for real analysis one, so the first year module, and it was around like 35 or something like that, which is lower than I expected. I didn't think it'd be high, but that was lower than I expected. In the end, I got 69. So yeah, I was 1 percentage point off of a first class grade. Damn. I would have got it if my tablet didn't mess up on one of the assignments and didn't like submit an entire question that I got correct. It didn't submit. Annoying, but that's all in first year anyway. Doesn't matter now. Yeah, Cauchy mean value. So this is what it is. But yeah, it's good to be back. Hopefully more regular uploads. I'm planning on doing a thing where at the end of each week I kind of talk about what happened in all of my lectures. That will be good revision for me and also keep me posting. But yeah, the undergrad is signing out.